Good day and welcome to your teaching primary science course. This video will deal with approaches to teaching primary science, a lecture on this topic. And before you continue watching, please make sure that you have already watched the recent videos specifically about theories and principles of teaching primary science. So I think this is the fourth video and this is the final part of our module 3 or unit 3, which is all about theories, principles, and approaches to teaching primary science. So let's start. We will be discussing 11 approaches to teaching science. And we will start with the first one, integrated or integrative approach. Now, integrated or integrative approach, the purpose of this and the relation of it to teaching science is that we integrate disciplines to the real world. We try to communicate what we have learned or what the students have learned in the classroom towards the real life situations or authentic scenarios. Now, an example of integrated approach is the intradisciplinary integration, wherein we try to incorporate what they have learned, for example, within science disciplines or branches of science, kumbaga. We try to incorporate what they have learned in those disciplines into real life situations. Like, for example, if they have learned concepts and skills about biology and chemistry, ang ginagawa ng interdisciplinary integration is that their knowledge in these two disciplines will be used and applied in real life situations. So magtutulong-tulong itong dalawang disciplines to integrate and integrate the learnings to real life scenarios. Ang interdisciplinary naman, this is when science as a subject, that's a discipline pa din, science as a subject, and math as another discipline will be joining hand in hand to develop concepts and skills which they both share and apply it to real life scenarios. And then for transdisciplinary naman, this is an integration of everything that they have learned and not to focus on a certain discipline, but to move beyond the classroom as a whole. Okay, so yung focus nila not to understand, not just to understand disciplines, to learn more about disciplines, but to apply all of the disciplines that they have learned beyond the classroom. So it transcends, kumbaga, the four corners of the classroom. The second one is the interdisciplinary approach. You might be wondering, magkaiba itong interdisciplinary integration and interdisciplinary approach. Now, interdisciplinary approach is the interconnectedness and interrelationship and interaction among various disciplines. Dito, pag sinabi nating disciplines, it refers to branches of science na ginamit natin in the curriculum. For example, physics, chemistry, biology, earth, and space science. So those are the disciplines. This is the transfer in interdisciplinary approach. There is a transfer of knowledge and skills. Kindly take note of that. Again, transfer of knowledge and skills. Sa third naman is multidisciplinary approach. Now, what happens here is that there is a transfer of knowledge, but hanggang doon lang. Knowledge lang. Okay? Now, knowledge, for example, from one discipline to another or vice versa. It utilizes contents and perspectives from two or more subject area into a lesson. Pwede yan. Next is disciplinary approach, also known as subject or traditional approach, can be observed when each subject is being taught separately. It paves the way for an in-depth understanding and specialization on a certain discipline. Now, ano yung pinagkaiba nilang lahat? Now, let's start with disciplinary. So sa disciplinary, again, the purpose is to master a certain discipline. So for example, this red one is physics, and in chemistry, yung orange and yellow is biology. Now, sa disciplinary approach, if you are going to use this approach, ikaw yung tipo ng teacher na magfo-focus sa isang discipline in order for your students to master that discipline. Okay? Kaya siya traditional or subject approach. You do not connect with other disciplines. For example, sa science, maraming discipline yung science. You do not connect the concepts from physics to chemistry to biology. Okay, isolated lang. So yan yung tinatawag nating disciplinary. No connection at all. It involves or it assumes mastery of learning. Multidisciplinary naman, as you can see here, there is a connection, but there's a quiet connection lang. Okay? Hindi ganoon ka in-depth yung connection. Pag sinabi nating multidisciplinary, this is when the science disciplines are presented using knowledge from other disciplines. Okay? For example, sa physics, merong similar concept sa chemistry. The teacher can use this knowledge, these concepts from these disciplines and explain, for example, explain mo yung physics, gagamitan mo ng chemistry, or si chemistry, you can use physics to explain it. Okay, so you are going to use perspective and knowledge. There is no in-depth relationship. Pagdating naman sa interdisciplinary, the difference is that it transfers knowledge as well as skills. So for example, they have learned knowledge and skill in physics, they can use it in chemistry. Then yung knowledge and skills in chemistry, they can use it in learning biology. So that's interdisciplinary. There is an in-depth relationship because again, there is transfer of not just knowledge, but also skills. Transdisciplinary naman, again, this is an integration of the all of the learnings inside the classroom, and then it transcends beyond the four corners of the classroom. So real life applications na yan. Again, interdisciplinary, there is an in-depth relationship, transfer of knowledge and skills. Multidisciplinary naman, transfer of knowledge lang. And disciplinary, isolated. There is no transfer at all, but there is a mastery of learning. Okay, so you can use or jump from one approach to another. It depends on your science concept. Next one is spiral progression approach. This one, we have already discussed this. An approach where similar set of concepts are, this set of concepts are taught across grade level, magkakapareho lang, but with an increasing level of complexity, continuity, and progression. Okay, so this is the diagram that we've been using. So sa K to 12, this is for grade 3, tinuturo yung chemistry, biology, physics, earth and space science. Same set of concepts pagdating sa grade 4. And then as they reach grade 5, same set of concepts, but again, the level of difficulty is increasing. Okay, as they move along each grade level. So again, spiral progression, continuity, and progression. Okay. STS approach or Science Technology Society approach. This one is a problem solving approach. However, it is more specific. Okay. Now, in teaching science under STS approach, teacher enable learners to discuss societal issues that are relevant to science and technology. And then teachers must engage learners in problem solving activities. Now, teachers must also facilitate learning around problems and questions related to their daily living and environment around them. Teachers emphasize that the scientific and technological issues in the society is the organizer of learning. Now, in this part or in this approach, the organizer of learning, or like the catalyst of learning, the reason why learning exists is because of the issue or the problem at hand na pinapresent natin or pinapresent ng teacher or hinahanap ng student. Okay? But these are not just simple issues. These problems or issues must be related to, again, science technology. So it limits the problems, mas specific yung problems, dapat about science, about technology, for example, about the environment that they're living in, the artificially constructed environment, social environment. So these are examples of problems and issues which the students can try to solve under STS approach kapag ito yung ginagamit ng teacher. STS or Science Technology Society approach. Diyan lang yung focus. Number 7, contextualized approach to teaching science. Now, this approach highlights lesson by putting it into context. Therefore, science contents will be put into context. Pwedeng local context, national, or global context. Therefore, yung mga teachers, they should not just settle by teaching textbook style. Okay? We should apply our science contents into actual context. Pwedeng sa locality ng mga bata or pwedeng sa even in national level or global level of contextualization. Pag sinabi kasing contextualization, we are providing more meaning in teaching. Kasi nga, they're experiencing it. They are, the context that we are using are familiar to them, or di kaya the context might not be familiar, but they are given the opportunity to learn more about that context. So maganda yung contextualization, especially in teaching science, kasi there are a lot of science concepts that differs in context. Okay? For example, sa local natin dito sa Jensen, iba yung mga hayop na nakikita. Sa national, iba't iba din yung diversity ng mga hayop, especially in global level of contextualization, right? Iba-iba yung pwedeng mahanap natin ng mga living things. So that is very important in teaching science, contextualization. Now, problem-based learning, PBL, an approach to teaching science where learners encounter relevant problems, issues, or tasks. Now, you might get confused with STS and problem-based learning. When we say PBL, again, PBL is broader, mas wider yung scope niya compared sa STS, which specifically tells the students na mag-search lang ng problems, to look for problems that are science, technology, and societal problems. Pero sa problem-based learning, as long as it is relevant to science, to their science topic, pwedeng-pwede nilang gamitin yon as part of their learning. Okay, that's PBL, or problem-based learning, an approach to teaching where learners try to identify relevant problems, they try to provide solutions, and then create hypothesis, predictions, and then assess, and then find the results, report the results. So that's problem-based learning. Ang focus talaga ng problem-based learning is hasain yung scientific method the knowledge of the students in scientific method. Kasi nga problem, di ba? They start with problem, come up with results, generalization, conclusion. So that's the essence of problem-based learning. Number 9 naman, inquiry-based approach. From the word itself, this is an approach where the teaching of science revolves around seeking for knowledge and understanding through questions, more efficiently student-generated question. So pag inquiry-based approach, ang kagandahan niya is that students will be allowed to ask questions, and that is actually better for them to ask questions and for them to answer their own questions. Okay, so that's one feature of inquiry-based approach. Seeking for and developing the thinking skills of the children. They will be or the students will be able to develop their critical thinking skills. They will be able to develop their exploratory discovery skills, because again, by starting with a question, they can produce and they can develop more of their skills. So that's inquiry-based approach. Next, practical work approach. Science deals with the material world. So from the word itself, practical work, this is laden with observation, an approach laden with observation and manipulations of objects, materials, and instruments in the real world. So this bridges the content, the knowledge that the students learn from the textbook into the real world. It bridges it bridges the cognition of the child and the application of what they have learned. That's practical work, because science does not reside only in their mind. It should be applied They should be able to manipulate. They should be able to observe, use instruments, or di kaya test, measure, mga ganoong mga ganoong mga activities. So that's part of practical work approach. Kasi nga in science, we teach them how to measure, we teach them how to observe, we teach them how to use laboratory equipments, we teach them how to conduct experiments on their own. So that's part of practical work approach. And that is very helpful in teaching science. The last one is literature-based approach. Now, literature-based approach is not a standalone approach. Okay? Kasi if you're going to use literature-based or di kaya yung kanina, yung practical work approach, hindi din siya standalone. They should be integrated with other approaches. Kasi nga, for example, if you're going to use literature-based approach lang parate, what happens is that purely textbook, books, magazine, newspapers lang yung basis ng learning ng bata. They cannot apply it. They are not able to understand how things work. What happens if they do this, if they apply that. So that's literature based approach kapag standalone siya. I mean, kapag isolated siya. Okay? Hindi kasi nga again, hindi siya standalone. And kapag practical work naman without the use of facts and information from textbooks, makukulangan din sa content yung mga bata. Puro lang sila manipulation without knowing what they are doing. Okay? So practical work approach and literature-based approach, they are not standalone approaches. Kailangang magsama-sama yan sila. Okay? So, literature-based approach, ito yung mga some of the well-known literatures used in science, yung mga almanac, mga encyclopedia, and National Geographic for kids, pwede ding mga ganyan. So, pag sinabing literature and in science, lalo na sa science, let's avoid using fiction books. Okay? Kasi nga factual and evidence-based yung teaching of science. Okay? So that's it. That's the end of the last part of our unit 3, approaches to teaching primary science. Okay, so congratulations. Natapos din. This is the final and I'll be meeting you synchronously. I'll be announcing it, but again, for this video, thank you for watching and I'll meet you and see you in the next videos. Bye.